Hi guys, hope everything's going well. We're in the home stretch now. We'll be done in, about a month exactly. And then it'll be summertime. Weather's getting nice, which is great. So this is example 2 in section 8.2 on page 447, and I'm just going to go through it with you. I've written down some of the givens here. We are asked to consider the plane with these two direction vectors, A and B, and through the point P0 or P0, whatever you want to call it. And the equations for the vector equation of a plane is analogous to the vector equation for a line, except that you have an extra parameter because you have two direction vectors instead of just one to define the plane. And then this equation is just writing each of the vectors in component form or Cartesian form, which will help us to find the parametric equations, because for part A we're asked to find the vector and parametric equations of the plane. So starting with the vector equation, it's fairly simple. We just take our point P0 and write it as a position vector OP0. It means it goes from the origin 0, 0, 0 to 3, 7, 0. And basically all that means is that you change the round brackets to square brackets to make it a vector, so that we can sub it in for R0 in the vector equation of a plane. And so the vector equation of this plane would be 3, 7, 0, which is our R0 vector, plus t times one of the direction vectors, let's use A, 8, negative 5, 4, plus s times, of course this should all be on one line, but I write too big, so I'm going to the next line. Parameter s times 1, negative 3, negative 2, which is our second direction vector B. Now to turn this into parametric equations, we just need to equate all the first components in each of these terms to get the parametric equation for x, and likewise for y and z. So x would be x0, oh sorry, I'm doing it in general, I should be doing it. Actually, let me go to the next page and I'm going to do it here. So x would be 3 plus 8t plus s, and again that comes from all of the first components in the vector equation. Y would be equal to 7, first middle component of the point or the position vector P0 plus, or minus in this case because it's negative, middle component of the first direction vector times the parameter t minus middle component of the second direction times second direction vector times the parameter s. And z, we do it in the same way, is going to be 0, which we don't need to write, so 4t minus 2s. And so these are the parametric equations for that same plane. That's part A. Part B, determine if the point Q, negative 10, 8, negative 6, let me fix this negative 10 here, is a point on the plane. So if this point is on the plane, then it should satisfy the equation of the plane, and these parametric equations here are essentially put together. The three of them are the equation of the plane. So this means that I should be able to substitute in this point for x, y, and z and find parameters t and s, the same parameters t and s that will work for all three equations. Okay, so I'm going to start by subbing in negative 10 for x in the first equation, 8 for y in the second parametric equation. Oops. And negative 6 for z in the third. Now we have a system of 3 equations with 2 unknowns. We know that we can solve any system that has the same number of variables as equations, and so therefore we can definitely solve for s and t because we have one extra equation. So we can choose to use any 2 of these equations. Let's use the equation number 2 and 3 to solve for s and t, the unknowns. But the trick here is that those parameters s and t must also satisfy equation 1. If they don't, then they don't work for all 3 equations, and therefore that point is not in the plane. So let's see what happens when we try and solve equations 2 and 3. And we could have chosen any 2 of the equations, it doesn't matter. So how can we solve equation 2 and 3? Well, first of all, let me just simplify equation 2 a bit because I've got like terms here with the 8 and the 7. So I'm going to make that into 1, taking the 7 over to the left side, equals negative 5t minus 3s. And then equation 3 is negative 6 equals 4t minus 2s. So we need to go back to our grade 10 methods here, and we can solve either by substitution or elimination. I'm going to do elimination. So I'm going to multiply equation 2 by 2, which will make this term negative 6s, and therefore I need to multiply equation 3 by 3 to make this term negative 6s. And then I'm going to subtract the equations to eliminate the s terms. So this becomes 2 equals negative 10t, multiplying the first equation by 2, every term. And the second equation, every term by 3, negative 18 equals 12t minus 6s. And now I'm going to subtract the second equation from the first. I'm putting my answer over here because I don't have room to put it there. So 2 minus negative 18, that's 20, equals negative 10t minus 12t, negative 22t. And I think I did something wrong because that does not seem to make sense to me. Alright, let's just go with it and see what happens here. So t equals 20 over negative 22, and if we reduce that, that's negative 10 over 11. Okay? I think I may have made a mistake, but let's see what happens. So going to the next page, we need to now, we got t equals negative 10 over 11. S, we can take any of the either equation 2 or 3. Let's take 2. 1 equals negative 5t minus 3s. 5t minus 3s. And let's substitute in t to solve for s. So we have 1 equals 50 over 11 minus 3s. 1 minus 50 over 11 equals negative 3s. That's going to be, let me grab my calculator here. 1, so 11 over 11 minus 50 over 11, so it's 11 minus 50. Negative 39 over 11 equals negative 3s, which would be negative 39 over negative 33. And reduce that to lowest terms. I can divide both by 3. be 13 over 11. So by solving equations 2 and 3 together as a system, I have that the parameter t equals negative 10 over 11 and the parameter s equals 13 over 11. So let's now check and see whether this satisfies the first equation. So going back to the first equation, we had negative 10 equals 3 plus 8t plus s, and t equals negative 10 over 11, s equals, let's go back and check, 13 over 11. So we can do a left side, right side check. Left side is negative 10. Right side is 3 plus 8 over negative 10 over 11 plus 13 over 11. Doesn't look to me like it's going to work, but let's just go through the motions to find out. So I'm going to give this 3 a common denominator of 11. So 33 over 11 minus 80 over 11 plus 13 over 11. And unless we get 110, that's not going to work. So plus 13, I got negative 34 over 11, which is definitely not equal to negative 10. So the left side does not equal the right side, and therefore values of s and t that satisfy all 3 equations do not exist, and so therefore negative 10, 8, negative 6 does not satisfy all 3 equations of the parametric equations, and therefore is not a point in the plane. Now I just want to go back a minute and make sure I didn't make an error, a calculation error over here. So I'm looking at where I solved by elimination here. So I had 8 equals 7 minus 5t minus 3s. Yeah, that's 1 equals negative 5t minus 3s. Okay. And then I multiplied this by 2. 2 equals negative 10t minus 6s. 3, negative 18 equals 12t minus 6s. Subtract them. 2 minus negative 18 is 20. Negative 10 minus 12 is negative 22. Oh, looks like I'm good to go. All right. So there you go. It's not a point on the line. Okay. Part C. Part C, sorry, on the plane, not the line. Find the coordinates of two other points on the plane. So I'm not going to go through this in detail because it's fairly straightforward. All you need to do is choose any real numbers for s and t that you like, the parameters in the vector equation. And you can have a look at it in the textbook if you like, but basically they just chose t to be equal to 1 and s to be equal to negative 1, and then t to be equal to 2 and s to be equal to 1. But as I said, you can choose anything you like, any values you like for s and t. They don't even have to be integers. They can be any real numbers, but obviously it's neater if they're integers. Part D, find the x-intercept of the plane. So let's go over here. So if it's the x-intercept of the plane, then y and z would both need to be equal to 0. Easiest form to use here would be the parametric equations, because we already have them in terms of x, y, and z. So x equals 3 plus 8t plus s, y equals 7 minus 5t minus 3s, and z equals 4t minus 2s, just to remind you the parametric equations for the plane. So I'm going to replace y and z with zeros because I want the x-intercept. And once I do that, I can then solve for s and t by either substitution or elimination. So let's go ahead and do that quickly. This time I'll do substitution just because I don't have a constant term in this equation, so it's easier to isolate one of the variables. I'm going to isolate t in terms of s. So t, change my mind, because if I do that I'm going to have a fraction, but if I do it the other way then I won't have a fraction. So I'm going to isolate s in terms of t. So I'm going to take the negative 2s over to the right side, make it positive, and then divide both sides by 2. And so I get s equals 2t. And then I'm going to substitute that into, let me number these equations, 1, 2, and 3. So I'm going to substitute this into equation 2 to solve for t. So equation 2 is 0 equals 7 minus 5t minus 3s. 0 equals 7 minus 5t. I got to be careful because my s's look like 5s a lot of the time, so I thought that was an s. Minus 3 times 2t. I'm substituting in s equals 2t. 0 equals 7 minus 5t minus 6t. 0 equals 7 minus 11t. 11t equals 7, t equals 7 over 11. And so with that, I can now find s as well, which I'll do up here, because s is 2 times t, so s is going to be 14 over 11. And now that I have values for s and t when y and z are 0, I just need to substitute them into my equation for x, and I will get the x-intercept. So let me do that on the next page. S is 14 over 11. T is 7 over 11. X equals 3 plus 8t plus s from the first parametric equation. And so I just substitute in s and t. T is 7 over 11. S is 14 over 11. And then I get an answer for x. And so x comes out to 103 over 11. Therefore, the x-intercept is 103 over 11. Don't forget to write it as a point. 0, 0 for both y and z. The end.